Hello. Hey, can you hear me? Hello.
Yeah, we
Hello,
can
hello,
hear you.
hello.
Hello. Can you hear me okay?
Yes, we can.
I don't hear audio clearly. Hello. Can you hear
Test,
me
test,
fine?
test.
Just checking one more time. Can you hear me okay? Something is wrong.
Yes,
Yes.
Oh, you can.
I
You
can hear you.
Good to know. Good to know. I was wondering if you can hear me. So if you can hear me okay, then that is good. That is good. So I am going to switch a couple of things and then we start talking about what we did the other day a little bit, and then we will, we ran into a problem the other day, if you remember and recall. That problem was basically a syntax change. You remember that thing I was trying to accomplish in running a. Why is the mouse not behaving properly? Hold on. My mouse is not behaving really nicely. Come on, mouse. Talk to me. Talk to me nicely. How about now? Yes. Okay, the mouse came back. So I was talking about the exercise that we did was about using Terraform, and you remember that I got stuck. If you remember and recall, the place where we got stuck was in which I mentioned in Slack chat, which is somewhere here. And so why can I not see that? Okay, there it is. So here I have updated that exercise a little bit to match the new requirements of syntax for in the develop branch. So we have a branch called develop and a branch called master, which was the old branch. And so if you go to the new branch, it supports the new version of Terraform. If you stick to the old branch, it does support nicely with the old version of Terraform. So if you want to use the newer version of Terraform, you need to check out this develop branch. And that's what we intend to do as we proceed forward. I will start that VM again and quickly walk you through the entire exercise that will give you a good solid perspective on how do we repeatably construct our design that we have in mind for our usage in the context of using in this example, Amazon Cloud. And we will recreate a bunch of technologies along with it. Like, for example, we'll also have a VPN machine. We'll also have a jump box. We'll also have load balancer and a scenario where we can play the elastic load balancer and see how to make that, put that to use. And we will do all of these things in the Northern California region because that's what this exercise is designed to work in. So I'm choosing that region, making sure that I go to the right region, which is the Northern California. You can always change the exercise and then it will work to a different location, but the default that I have chosen is Northern California. That's what that's why I'm heading there. I also have one VPC, which is the default VPC that you see here, which is not what we are going to use because we are going to construct our own new, separate, independent virtual private cloud through that automation that we have. And that is what I'm trying to bring up in front. And so in here, I have this virtual workstation that I want to put on one side, and then the Amazon view on the other side, and make it a little smaller on the Amazon side. And here, open up my terminal. In that terminal window, you will find that I have a folder called Terraform, which is that exercise that we did the other day. If you go inside that exercise and say git status, you will find that it is not a git repository. How come? Because I did not go in there. So yeah, git status, you will find that it is a repository, which is the develop branch. you can check out a different branch also and play with that for the older version of code. The code Terraform that we have in our machine right now, Terraform, if you check the version of this that is currently installed, I have updated it to the very latest one, 0.78. And I did that in the process of debugging the other issues. And I finally was able to debug it, find out that it is actually a change in Terraform core that requires a slight different syntax. And the entirety of change that I actually did was this. I'm going to pull up exactly what I changed. It's a very tiny little change I did that you will see in here. What I did was remove this slash here and here that I had before. The red lines, this red cross, red colored highlight shows you that I changed something here. And then I replaced them without the slashes. So you will see here, there is no slash and also no slash here. That's the one change I did. In addition to that, another change I did was to include, or rather remove those slashes again in another file for key pairs. That's the place that I was getting stuck. If you recall, in our folder here, I was getting stuck with key pair. So the key pair has a reference to these backslashes. In the older code required it. The newer code barfs when you have that slash in this section right there. So the codes need to be escaped before. Now they do not require escaping. That's the only difference. In addition to that, I have also modified an open VPN server that we want to use. So we'll include that change already. And all of these things are included in the exercise, which has now been updated and is available on the GitHub location for all of us to use. So as a basic fundamental step, what I will do is somebody's pinging me. Hold on. And so I don't know who pinged me. If any of you is pinging me, I need to, Dennis, okay. Oh, Dennis was that. So that was Dennis, no problem. So hey, Dennis, I understand your question. I'll thank you. And so let's see, Dennis is online. Yes, he's there. So you're watching the thing that we are doing, which is primarily what I'm going to do is get rid of this entire folder and bring fresh content from GitHub. That's what I intend to do. So I will remove that folder, which is this rm-rf tf folder entirely. So it is gone. I don't have anything right now. After having cleaned it up, I will go to this sort location and grab that clone URL and copy it. So basically use the HTTPS link and copy, and then say git clone, and then paste that link over and use a short tf folder name. So it's not that long folder name, but a short name tf. And that folder gets created. We'll go into that folder and we will find that the git status is actually checking out master branch. And this piece of code, if you open up in the editor, you will have a bug that works only with the older version of code, not the newer version. And so the bug is basically this, and this needs to be removed. Similarly, the same thing in another file, you have to have this slash, and this slash needs to be removed. So we'll do that by checking out a different branch that I have created for us the other day. And that branch is called develop. So we'll do git checkout develop and just check out a different branch. That's it. So now our git status shows that we are in a different branch, which means our file systems changed completely. And so I should just don't save it and then open it up again, and you will find that those slashes are gone because I killed them already in the develop branch. They don't exist anymore. These slashes are missing, which is exactly what we wanted. So now that we are in the develop branch, and that our Terraform version is actually the very latest version that I have. So I have updated that version, and you have instructions on how to update it in your Slack chat. And I'll give you again if you like. not here, in here, this Slack chat you will have, and that's where you can find how to revert back to the older version of Terraform. So this is the instruction that I used for older version of Terraform, but very similar. You just change these version numbers to get the newer version of Terraform. The process is pretty much similar, except the version numbers change. You can get 078 instead of 0616. That's a newer, older version. You can just change versions. Just remember to check out the develop branch for the latest version of the code 078 so that this works properly. Having understood these pieces, I want to now walk you through the same thing that I was doing the other day when I did not succeed. So I want to go to that TF folder one more time, and that is TF folder here. And inside there is Terraform, and then there is this whole folder, which is where I want to dump things. So I'm going to basically move these things away. So here, 1, 2, 3, 4. I'm just hiding these things away. And then I'll bring these things back when needed, one at a time, or maybe a couple at a time. And that's what I will work with. So these two files, one contains the variable definition, and the other contains the string that I want to change, called change this. This is going to be my credentials. As usual, I have deleted my credentials for security, which means I need to create a new one. So I'll do quickly. You know this already. You know the drill, which is to make sure that you are never, ever releasing your credentials to the public. You keep them separate and safe. So I have the credentials here. I will just copy them. And these credentials do not have teeth yet. So I'll give them teeth. But for right now, I'm just copying them over into the change this location and pasting them. And by the way, for those of you who will play with this exercise at a subsequent time, please do not check this particular file in your Git repository, because if you do, it goes to GitHub accidentally and you will have a disaster. Do not leak these credentials. So having said that, I'm closing those credential file, saving it. And now we will run the concept known as tell me what the plan is. So Terraform, tell me what the plan is. So it says I cannot find Terraform because I'm in the wrong folder. You have to go one step below. And so Terraform folder, and then say, okay, show me the plan. And it will go connect to the cloud and find out what the plan is. And currently there is nothing to do. So it says no changes needed. And now we will start bringing them back. What we need to do is bring those items from the whole folder out one at a time. And before that, I want to give some teeth to this key. So I have those key that I have constructed. I want to make sure that I give some teeth. And so I will close out and add this user to a group known as super duper admin so that the user gets appropriate authority to act. And then we'll go back to the Northern California VPC section and look at the whole folder and say, you know, this AWS VPC, I want to create a new VPC called automated. So I need this file out in the Terraform folder. And then I will say, okay, show me your plan again. So Terraform, what's your plan? And the plan happens to be, first of all, go look, if you have an automated VPC already there. No, we don't. So it's going to add one, simply. So when I say Terraform apply, it adds one. It goes to the cloud, creates one, and we'll see it happening live. We'll go on the left side, refresh it, and we'll see a new VPC showing up. That's there. 2 VPCs now. We have one called automated, created. Next, what I want to do is understand what I want to do next. So I want to rather construct a public subnet. I want to do that. I'll bring that outside out of the whole folder. I want to create a public subnet. I'll go back here and say, show me the plan. The plan is to construct a public subnet that you don't have. So it's going to create a public subnet. There are 4 things to do. So create a public subnet, create a route table association, and also create a route table itself and a gateway. Those 4 things are defined in this file, particularly right here. Create a gateway. And so it creates that gateway, creates a subnet, creates a route table, and then makes that association. So that's what we do by hand in here on the right, on the left side. If you want to do it by hand manually, you can, but it's boring and it's not automated. It's not convenient for a large scale. So you use this method. What you would do is now say Terraform apply. So it will go and construct a new subnet for us and a gateway and associate that gateway with our these four things added. So we'll go and examine what it had done. So we'll go to our automated VPC, and here you will find that there is one gateway attached. There is a route table constructed for this one, and the route is actually making use of the gateway that we have created. It is also associated with the subnet called public, which also got created. So that was this public subnet. Next, you want to create a private subnet. It requires a NAT device. So we have to have the NAT machine there. But to create a machine, we need to have a key pair. So we need to have the key pair also included. The key pair we'll use is this key pair, the public key that I have. It will be sent over. The first thing I want to take is this key, put it in the Terraform folder, and say, tell me what the plan is. And say, you know, you don't seem to have your key there. I'll add the key now because that's the new thing, right? So add key pair. We'll have to add that. So we'll say, okay, go add it. So we'll go back in the Amazon console and find that in EC2 section, this new key gets added called, the key gets added by the name, key pair, and it's called automated VPC. That's the name we have chosen in the key pair file here. It's called automated VPC. That's the name that you see right there, and the fingerprint matches this public key. Next up, what I want to be able to do is, now that I have a key pair going, I want to actually start using this key pair to construct some machines. But before I create a machine, I want to make sure that my security groups are set properly. So I'll bring that security groups file out to the Terraform location. Now in the Terraform folder, I have a security group file, which is new. So I want to construct and ask Terraform, hey, what's the plan? And it'll say, you know what, the plan is to add three things. What are you going to add now? So we're going to ask, we'll say, you know, AWS security group is to be added for the web security group. We'll also add a security group for NAT. We'll also add a security group for default traffic. So we have three-part security groups. One is a default security group. One is for NAT security group. And the third one is for, come on, what was that for? Third one is for the web applications. We'll have to have in our design, we will create something like this at the end of the exercise. What we will end up with is what I will like to draw right now. We will come up with, okay, let me erase these guys quickly and get rid of these elements that we don't need. We'll come up with something like this box. Okay, it should be on top. So this item should be on bring to front. No, bring to front. There. And then I'll have two boxes, two Docker containers, by the way, one here and one there. And we will do some load balancing. And we'll also have another subnet like this that will construct to accommodate our public subnet. So we'll have one more like this. And in here, we will put a NAT device. So we'll have a NAT box, a NAT Docker container here. It will be a Docker container. All of it will be Docker, by the way. It's a whole lot easier if you run it in Docker. So this NAT actually will be running inside Docker. In that box, we'll run a OpenVPN server. That will allow us to go inside this cloud area, this entire area. We'll also use a load balancer system. So it is basically going to help us in balancing our load between the two web application servers. Those are going to be this box and this box. Actually, this container and this container both will be running Nginx, the web application that I want to use. So we'll have one container here in two different availability zones. And this is going to be a load balancer. It will balance the load between this and this. That's the output that you will see at the end of this run. So up until now, what we have done is constructed a public subnet. We have constructed security groups. So this is the public subnet. We have constructed a security group for it. We also have defined a key pair to use so that we can construct machines out of it. We'll construct one machine here, one here. And then we'll also use this as a NAT machine, and then use this NAT device to construct this private subnet. And then in that private subnet, we'll create these two boxes, then insert Docker here, insert Docker here, insert Docker here, and use OpenVPN. And then you will play the entire scenario. We'll walk through step by step how things are working out. We'll do some load balancing and understand how load balancing works and things of that nature. That's what we intend to do in this exercise that we could not succeed because of this change of slash, this syntax change that happens between version 6 and version 7.06 versus 0.06 versus 0.07. Something changed in Terraform that I did not notice, but then I did yesterday, and then it is working now. So let's back here. What I want to be able to do now after constructing is to look at the other remaining items that we have here. And in our hold folder, we still have the application servers. So this file will construct those two app servers, this one as well as this one. That's what this app server file will do, is construct those two little boxes on your private subnet. So we'll do that later. First, we need to have the private subnet going. But for that private subnet to correctly work, we need the NAT device going on the public subnet. So this is the next logical thing we need to put, is the NAT device, without which we cannot really have a private subnet. The public subnet can exist with a gateway that we constructed. And so it is able to configure, and it works. It will let people that sit here go out through the direct connection to a gateway on the public subnet. That is fine. But private subnet, you cannot really complete its construction without having a NAT, a route to go out. And that is the thing that we need to construct first before we create this. So back here, the NAT server needs to be constructed. So we'll bring it out. And at the same time, bring public subnet also out. So at this moment, we have two new items, one for your NAT device and one for a public private subnet. So we'll go ask this guy, hey, what's the plan? So we'll say Terraform, what's the plan? And it will tell us what the plan is. It is calculating that. It's comparing nodes with the cloud, with the actual Amazon cloud, and says, you know what, you don't seem to have this thing. Let's see what it says. So we'll read the plan. The plan is begins in this is the point where we began. It went out to the cloud, tried to study its state. In that state, it finds that there is no NAT instance yet, so it needs to be created. And once you create a NAT instance, then you need to make sure that the private route table also needs to get created. And then you have to associate this private subnet that you will create. You have to associate that with the private route table. You will also update the default security group so that traffic flows properly. You will also create a NAT security group so that the NAT traffic allows SSH access and HTTP access. You'll also update your security group for web so that port number 80 can be accessed from outside, and 443 for machines that are going to be hitting this box, which is a load balancer. This may be hit with port number 80 or 443, depending on traffic, whether it's HTTP or HTTPS. And accordingly, it will open up access to these boxes as long as the traffic originates from the load balancer, allow 80 and allow 443. That's the security group change we have to construct in this. That's what we are doing in this particular segment. If you keep scrolling down, what else will change? It says I'll create a private subnet. And that was the plan. So if you just execute this plan, it will do those things for you. Meaning it will actually create a box, which is going to be a NAT box, and deploy it right there, here. Then it will create a private route table, create a private subnet, appropriately adjust your security group permissions, put things together. You can see them happening right here, right now, as it constructs a new machine image for using with NAT. You will see that a new box pops up here, and it is this, and that is going to be our NAT. It has a name NAT already, and that is getting basically provisioned right now with remote execution. So it is remotely connecting to that box with SSH and actually making that box, converting it into a NAT device through scripting. You may have heard me say that you can configure a box using a scripting method to convert a regular plain old Linux box, make a NAT out of it. That's what this is doing right now, by the way. It is adding this line, one simple line that enables forwarding route. This line, you echo 1, the value 1, in this file called proc.sysnet IPv4 conf all forwarding. Basically means you write number 1 in that file that enables the forwarding method for IP tables. And then you modify IP tables and update to construct a NAT, which is going to masquerade your traffic. This masquerading or traffic you may have heard of me talking about in a video a while ago in technology section, module number 11. And that's what masquerading is in a regular router or a NAT device. That's what this thing is getting constructed. So in line, you will write remote execution code on that plain old Ubuntu box and convert it into a NAT on the fly. And that's what's going on right now. You can see that it is updating that particular NAT box, and it's going to reboot and get it ready for us to use. And at that time, we should be able to find that it reports back success saying we constructed a NAT device for you. We also will see that it has updated all the security groups. So we'll examine the security groups also. We'll also have this private route created, which goes through the NAT like this and like this for going outside. You will also have a public and private subnet and a route table, and appropriate routing for private areas go through the NAT, and for public subnet there is a public route table that gets traffic going out through gateway without having to go through a NAT. And those things, you will see this thing, and by the way, it succeeded. It says 7 things added. You can see what it added, basically all those things. You can scroll that back up, and it's probably too long. It's probably overrun the buffer. So I cannot even go to see all the history in this, but it shows success. It did what we wanted it to do. So we'll now finish up with our remainders, which is I want to actually construct those 2 application servers. So these 2, I want to not only create application servers, 2 in number, using T2 Micro in the private subnet, using my key that I have in with you. And when you create those boxes, by the way, I want you to run this special YAML configuration. What is that cloud config app YAML? It basically installs Docker in there. So if you go look at cloud config app YAML, it is a line installing Docker. It installs Docker and then runs Nginx, Docker container. So 2 lines basically. This is the custom configuration that you want to run inside that app server, which is what this line will do, is go to that app YAML file and install Docker and then run an Nginx container on those boxes here and here. We will have Docker plus Nginx. They're going. Once we execute this app server.tf. And at the end, we want to see what all you did. Like give me an end result output. So I want to see that output also. So I'll move this file out to Terraform and also outputs file in the Terraform folder. And then we have basically everything outside of hold. So nothing is actually held, which means we can now take that next logical step of going back here and asking Terraform, hey, what's the plan? And so it will tell us what the plan is to add 2 new boxes and install Docker in there, install and run Nginx. And so here it will update the security groups accordingly, because new machines are getting created. It will force use of new resources. It will also, construct two machines up there. You will see that it tells you that it is going to create a load balancer, elastic load balancer. It will construct by this name, VPC ELB. It will also construct a box called app0 and another box called app1. These two boxes that will be balancing the load on the load balancer. And then this NAT instance you have, you want to make sure that you force it to use new security group because of new resources getting in place. So you have to update the security group definitions. You will also modify the private route table and include these new instance IDs that are getting constructed. And that's the change you will do. And you will destroy older security groups, construct new ones, and create two new boxes, one load balancer. That's the plan. So we'll say, okay, go do that plan, please apply. So it goes to the cloud, does it for us. So you will see now that it constructs these two machines and configures it just the way we want. So we will now understand what the cloud will look like. We'll go to Amazon and see it directly there. At this moment, it is still working, so we'll let it finish that job. We'll put this on the side, by the way, here. Oh no, close. And let it run on the right half. On the left half, we'll make it a little bigger and see what is going on. And so what I'm going to do now is refresh, go to the Amazon dashboard, EC2 dashboard, and we look at how many instances we have. And so it is going to kill that NAT device and create a new one. That's what is going to happen. So you see that the NAT is getting shut down right now. You will also see that a new NAT box is getting created as a part of this apply process. So it will construct a new NAT box. It is still busy destroying. So when the destruction completes, it will construct a new NAT. So it is now creating a NAT. So you should now see on the Amazon account a new NAT getting constructed. And it is pending right now. And the older NAT is dead. The new NAT will become your new NAT device. And the old NAT, which is dead, terminated, we can call it, relabel it as the dead NAT. And this one will get a new name called just NAT. That's what's going on. It is still creating right now. So it is timing it and then trying to connect to the machine that got created, and then insert your public key over there. Make sure that you're able to connect it through SSH, and then sleep for 3 seconds, apt-get update, and make that box a NAT box. That's what is going on right now in this file. You're basically converting this box into a real NAT box by making a change. The change is actually very simple, one-liner, but it's a fundamental change you need to do, which is to insert this number 1 in that file. You can see these things, by the way, in GitHub yourself. Even if this is not very easy to read, you have access to the code itself. This file we can actually go and examine after the fact and see that it has 1 in there. We'll also see that the IP tables route actually allow forwarding. We'll also see that it installs Docker in there and then installs OpenVPN software. That's what this OpenVPN server will be installed through Docker. So we'll use that OpenVPN solution momentarily. As soon as the things get ready, we'll be able to use those things. It is still waiting for NAT instances, still creating, and it is just finished doing that. So it proceeded forward. We'll then see 2 new machines getting constructed. They will be called app0 and app1. After this NAT business finishes, it will switch over to the other action, which is your creation of application servers. They will also pop up in the same list. And as a consequence, you will have our layout, which is basically what I draw here. Is you have a NAT box, and you have app0, app1, So let's call this A0, A1, NAT, and these three are running Docker. And in their Docker containers, you have VPN software, you have Nginx software, and another Nginx software. And these are three boxes, 0, 1, and N. This is the NAT box. And we have a public private subnet, we have public private route table, we have a gateway, and we have this NAT that is sitting on the public, but these guys can connect through the NAT and go out. So that's the scenario we are building. We are waiting for this to finish. Then we will go here and here, create these two boxes, insert, run Docker, and then create Nginx container here, Nginx container here. And the idea behind this load balancer is to actually balance the load among these guys. I should undo that color, maybe change a different color. So here, no, not good color. This and this is how it will balance the load among this load balancer. We'll do that for these users. And you can see as a user, when they hit this IP address, this endpoint, you will see that the Nginx running here is answering. And for the second person, Nginx running here answers, and the third person goes here, and the fourth goes here, and fifth goes here, and sixth goes here. And like that is going to, you can see that load balancing momentarily. Oh, it finished. So it also produced a nice little output for us. So this output, the output shows that you have app0 as an IP address, which is a 10.IP address, which is like internal only IP address. So if you try, take that IP address and say copy and say ping, and say try to ping it, it doesn't go anywhere. You cannot reach the cloud. It's in the private area. You cannot reach there. You just cannot, because it is not reachable, this private segment. You can reach here, basically this box, but that's it. Thankfully, we have a VPN installed right on that box. We'll use that VPN. But for right now, let's go check. What do we got? So we have 3 machines running there. One of them is dead. This is the dead one, but then 3 are running. The NAT device, which has a public IP. Nice. So that is the public IP I want to use. And so the other 2 boxes do not have public IP. They are the automated app 0 and automated app 1. Those 2 boxes do not have public IP at all. I mean, it's missing. That's a design that we don't want them to have public IP at all. Another thing you will see is that there is this load balancer that got constructed automatically, like here. There is a load balancer now we have. And this automated eVPC ELB is actually doing exactly what you want us to do. Is this is going to look at these 2 instances that are there. One of them is the automated app 0. The other one is automated app 1. You will see that those 2 instances are actually getting load balanced by this load balancer. And one of them is in service, the other one is not. So we'll talk about what's going on. We'll try to see and fix it. And that should also come back in service. So both these guys, app 0, app 1, both of them should actually serve our load balancer comfortably. And one of them is out of service for some reason. We'll find out what's going on, but we'll fix that one. It should automatically fix most of the cases, most of the time. However, we are now looking at this ping not responding. It is not expected. We are not expected to respond because it is inside the VPC. So we broke it. Even this IP address is also inside the VPC, which is not going to get connected, or you cannot ping it. It is not routable. This point is routable. It is the public-facing elastic load balancer. That's the name I want to use. This is the name that our customers will use. Our customers who want to hit our infrastructure, will they hit right here, and that's the name they will use for the ELB, the load balancer, elastic load balancer. So that's the name we have, which is this longish, this record, the DNS record that they constructed for us for our name automated VPC. We can use that name right there to hit our servers, our infrastructure. We have servers behind in a private area. However, we also know that there is this public IP address, which is our NAT IP address, which should be pingable. So we can reach there. So let's see, we can ping. It is on the public internet. We should be able to ping it. But I think ICMP are disabled in our security group. So ping may not respond. Even though you can resolve it, it will not respond to pings. So we'll break pings and instead connect to that box. How do we connect? We just say SSH root at and IP address, and it should just connect like this. But root is not the right user. So we have to use the name Ubuntu because it's an Ubuntu box. So we break it and then say SSH Ubuntu at IP address, and it should just let in. So we got it right there. So we have it here. This is the NAT box. We'll now examine cat etc or whatever that name was, proc etc something, right? So this file name, which proc sysnet or that long reference, we'll copy that reference, bring it here to the terminal and say, please cat for me. And you should have the number 1 in there, like that. This is an indicator that is actually forwarding the traffic to other boxes. It is acting like a NAT device. That's an indication. You can see that right there. That's all it takes to enable a NAT box. Another thing you need to do from a NAT device deployment perspective is to automatically disable source destination check. If you recall, you have, by the way, it's already done for you through automation. You can just go and check that it is already disabled. So we go into networking and look at our source destination check. It is already disabled. So we'll go and see for the NAT box, and source destination check is already showing false because that's how the code is written. You can see that in detail if you go back here and NAT server, and source destination check is false. It's already written like that. So you don't have to do it by hand. Most of the time, people forget doing this one thing, and then the NAT device will not function like a NAT device, which is unfortunate. And so people forget, and nothing wrong with that. That's what people are supposed to do. But machines don't forget. If you write it systematically, they will remember. And you just play, or you just apply, or you just run that to make it happen, repeatably happen. And that's the beauty of using machines to make it repeatable. Having understood that part, let's go see a couple other things. Like, for example, what I want to be able to do is that public IP address that I have now, that for the NAT box, I want to give it a good name, such as VPN for my company, something like that. So I'll go to my DNS, and in there I will log in, and then go to my domain and say, you know what, I want to give a good name to you, dear VPN. And so here's the name. It currently points to this random IP address. I want to remove that and put this instead, or not this, but the IP address, which is this one. So I want to get that IP address and put that in the name VPN, so that it becomes easy reference for me and we can just use it. So that's what I did. So I can now use this name vpn.cloudgenie.us to ping whatever I want whenever I want to connect to the VPN machine. I can use that name. So that name becomes available, which means I should be able to SSH and then Ubuntu at VPN. This should also work. And it did. So we got connected with a name. That is nice. After having done this part, let us go read a couple of other things. We want to get to this business of connecting to the machines inside comfortably. I want to connect here and here from wherever I am right now in my office. I want to be able to go there. Currently, I cannot, because there is this virtual private area. I cannot go there myself. I want to go there logically, not physically, logically. So how do I do that? I will use a VPN network. A VPN is something that we already have installed, by the way, right here. We just did that through automation. That is there. And we know this software runs in a Docker container. that software runs in a Docker container in this box right here. That box is called vpn.cloudgenie.us. We just connect it to the box because it is on the public subnet. We just connect it like this. We can go here, but not anywhere forward. I want to just randomly walk around my cloud and just connect to any machine I feel like. That's what I want to be able to do. And for that, I want to logically go to the cloud. You can do that totally easily because you have a VPN now. For that, you need to go to the bin folder and generate a credential for your employee in your company, allowing them to go to the private areas. That's the first thing. So you want to create a set of credentials for an employee who will do these things, who will have permission to go. So you are the first employee, by the way, in your company. So you will create a credential set for yourself. And you will do that following this README documentation. The first thing you want to do is to establish a certificate authority. And so we are going to map our IP address by this name that I just used. You can use any other name that you like. And initialize a certificate authority in that Docker container right here. That becomes the authority to who can issue certificates to all the employees in our company that will then logically place themselves inside the cloud and do whatever they want. That's the idea. So for which we need to run this simple one-liner, which actually is a long one-liner, not that simple. But here is what it does. It basically connects through shell, runs, uses our private key to connect to that box called 12, and uses Terraform output NAT IP, which is the NAT's IP address. So uses NAT at IP address of the machine that we want to connect to. And then inside that box, use the -t command, run Docker. And inside that Docker container, which we have installed, by the way, we are going to initialize OpenVPN PKI certificate authority. That's the thing that we want to do. It's fairly long to comprehend, but essentially we are running this command inside Docker container that we are already running inside the machine that we are accessing through SSH. So that's what this longish thing is. We will run it here, and you will see that I make it full screen and cat that bin and number 1 to see what we are going to actually execute, and then execute it. Here we go. So it will go to that location and ask us to create a certificate authority for which it requires a passphrase. So I will give it one and repeat the same one. And then it create. Did I make a mistake? No, thank goodness. So common name. I'm going to give it a name to this machine, like VPN dot. And then it is going to take some time to generate a very long prime number. And that prime number is now saved in that file. This is the Diffie-Hellman prime generator that gets saved in that file. Let's see OpenVPN PKI dh.pem. And that prime was saved. And now it is asking to create a private key on that box so that we can use this private key to generate certificates for other people in the company. And for right now, I'm going to give it a passphrase. And then it told us that it created a certificate authority, which is valid for 10 years and until 2026. And the database was updated with the certificate details that you have saved. This is your private key that you constructed, and this is the certificate authority that gets created in that location inside that certificate file, which is this one. And these things are stored in the VPN Docker container, which runs in your NAT device on your public subnet. And you are connecting from here. We just created a certificate authority. That's the step number 1. Next up, we'll do step number 2, which looks like this. And in here, what does it do for us? Let us first read what it does. It says, I'm going to generate client configuration for an employee by the name Nilesh. Okay, so here is how you generate a client configuration for Nilesh. So we'll take that command, but before that, we actually read what it does. So here, same concept. We are going to basically run EasyRSA, build a full client certificate for $1. $1 is the first parameter you pass, which is the name of the employee, in example, Nilesh. And so it's going to build a full client for the employee with no password. I'm just making it easy on myself to not have to have a password. I'm just skipping the password piece for easy, just to make it quick. You can actually include passwords also to further supplement security of a certificate. So we are creating a full client certificate for this new employee without any passwords. This is just making it easy for me. It is going to connect to that container that is running inside that machine called NAT. And the machine called NAT is this machine. Terraform output, NAT.ip address. Connected through Ubuntu using SSH, using this private key, and connect and run build client full, which is to generate a new certificate for this user called Nilesh. That's what will happen when I run this command. And so I will run it pretty much like this. So go create a certificate for this new employee. So it does that. It says, okay, I want to get the passphrase for you for this private key that you have there. So here is the passphrase for that. It says, okay, I created it. So that certificate is now available to us, but it is sitting here in this box. We want to bring it down here. I want to get that certificate for this employee called Nilesh. And that's what I want to do. So that's the step number 3, which is here. Step number 3 is to download that certificate configuration and give it to the employee. So we will download it through this 3rd step, which is also another Docker command, by the way. So I'm going to copy it from here, by the way, and go to the 3rd step. The 3rd step is again, similarly, OpenVPN client for user Nilesh. Output that to a file called nilesh-automated.ovpn. That's the file output I want to save it as. And you run this command inside Docker. Inside that container, running in that machine called Terraform output NAT IP, the NAT box. So you go connect to the NAT box first, then run Docker container. And in that Docker container, you run OpenVPN get client for Nilesh and output the file in this name. So you will see, as soon as I run this step, number 3, you will see a new file pop up in our folder, which will show up somewhere in this Terraform folder, this folder, a new file called Nilesh-OpenVPN, automated OpenVPN will pop up. It will come as it will get downloaded from that remote machine that you see is here. This number 2 generated. I want to bring it down to this machine number 3 right here locally. That's what I will be doing. So I'll run this to bring it down, and here it comes. It came. This is the file that came, Nilesh automated OpenVPN. Now, if you start looking at this file, it's fairly long, but it is self-contained. It contains everything that the employee needs to know to connect to the cloud, VPN connection to the cloud in the private area. So here you can see that this is a client certificate. It does not bind, does not use the bind server, which is the DNS server that you may or may not want to use. In our case, we don't want. There is a device that gets created called TUN or tunnel adapter. Key direction is 1. Remote cert TLS is the one that you will use in the server. The remote location is known by this IP address, and you have to go to this port for UDP for you to connect to the VPN machine over there out in that box, which is also the NAT box, by the way. And here is your private key. So it's a long one. Then we scroll down, you will find certain other parameters. There is a certificate showing up. This is a customer, this is the employee certificate that you have. It ends right there. And then you have further more elements at the bottom. You have another certificate and you have some static key available, which begins here and ends here. Then this key direction is repeated. I think it's already mentioned. Redirect gateway def1. And so certain custom specific parameters that OpenVPN would like to have, they are all included in this one simple single file that you have to basically hand it over to the employee. Now, when the employee receives that output, the employee can then connect, basically connect to that OpenVPN server. For that OpenVPN server to be connectable, you need to start that server over there. You need to run this command to start the OpenVPN server on the remote location. You have to basically execute this step number 4 to run OpenVPN and asking it to start inside Docker, inside that NAT device, which you connect through SSH. It's a multi-part complex command, but I have simplified that in form of simple one-liners that look like this. OpenVPN start. So simply asking this to start, that's what we are basically executing. And we will have this machine keep running OpenVPN server inside the container in the NAT box right here. And we will keep it running like a daemon, as you can see with the -d option. In the command, there is line number 4 -d option, so it keeps it running perpetually. So that's what what I want to be able to do is tell that box NAT to go inside Docker and run OpenVPN perpetually. Here we go. So it runs it. And it is running right now. And that's the ID number, 75F9, whatever number is. So that's the number. So we have OpenVPN server going. Now we have this new employee called Nilesh, who now has access to this key or this entire certificate that he has access to. So we just gave it to them. Now what we would like to do is ask the employee, hey employee, can you connect to the cloud and do whatever you feel like? And that's what the employee will do now. So you will actually now use a client software to connect to that cloud using VPN. So that client software actually needs to be installed. Not every machine will have a client. So the installation is this one-liner. You can run this one-liner on a Linux box. There is OpenVPN client for every platform you can imagine. So on this machine, we'll just run this one line, or not this line. Sorry, I want to get this line. So copy to run OpenVPN. Local client on the local machine right here. This is a local machine. So we are going to run it. It probably already has OpenVPN, but let me tell you that OpenVPN software is available for every platform. Every type of OpenVPN client is available for Windows, Mac, iMac, Linux, BSD, Solaris, Android, iPhone. Everybody has it. So basically, anybody can connect to the cloud as long as you have a proper certificate. So we have, in our example, OpenVPN client installed. Now we want to check whether we can actually connect to the cloud without using OpenVPN, and we did that quick check, right? We tried to ping this internal IP address, and it did not work. It is not routable, right? We also check a couple of things. I want to show you very, very succinctly what I mean by connecting to something with a VPN. So I'm going to see ifconfig, and here I will show you what adapters we have currently. So there are a bunch of them already, by the way. So we'll just make sure that we understand what of these things are. So this is a Ethernet, virtual Ethernet adapters. These are Docker, basically Docker creations. These are virtual Ethernet adapters you might see. They are not anything to do with VPN. This is a local loopback adapter, which is also not OpenVPN. What you will see once you start OpenVPN connection, you will see a new network adapter pop up. This is also Docker related. This is the actual Ethernet connection that has a proper IP address. This is local loopback, and everything else, vEthernets are virtual Ethernet devices. They are related to Docker usage. So we do not have any actually new tunnel adapter that corresponds to OpenVPN in our configuration in our machine right now. You just saw that in the ifconfig command. What I want to now do is actually use our OpenVPN certificate that we have given to the employee and ask the employee to connect to the cloud, pretty much like this. Before I run this, I want to run one more test to prove it to you that you cannot actually connect to that internal IP address at all. Even though you know that that's IP address 10.128.1.233 is a real one. You have this machine has this 10.128.1.233 is a real internal private IP address available, and a machine is up and running. Similarly, another machine, app1, is a different IP address, also internal, but no public IP address, available to you and up and running. We can try to SSH, and it does not work because there is no route to go there. You understand this. However, now what I want to do is in a different window, so new window, and I will use this window to run my OpenVPN, sorry, not this command, but run OpenVPN like this. So that command, I will use this separate terminal to connect and run OpenVPN software to connect to my cloud. And so here it goes. It is asking me for a root password, which is Cloud Genius. And it is attempting to make a connection with the cloud, and it finished. So it has established a connection. What does that do? Let us read. It says establishing a UDP4 connection. It attempted to connect to this IP address, which is our NAT box. Inside there, we have a Docker container where our OpenVPN server is running. That's where it went. And it created a new tunnel device, a tunnel adapter, TUN0. It got created. And we now have a local TUN IP address assigned by the VPN server. This address has been assigned to our machine, which is basically logically placing this virtual machine in the Amazon cloud. Basically logically placed myself into the cloud, which means I can do whatever I feel like as if I am there in the cloud right now. I should be able to operate on the cloud just like that, without any trouble. What does that mean? I will go here on the left half of the screen. On the right half, I have my OpenVPN connection in place. And on the left, I will just say SSH, connect me to the app0. And here you go. It lets you connect. And we got connected. And we did not do any jump boxes, none of that. In fact, all we did was put in a VPN connection in place. So we'll also see that we have ifconfig in work, which shows us a new tunnel adapter in place. So we should be able to find it. It is this new adapter popped up. It has this IP address assigned. This IP address is given to us by the NAT box. And that NAT box is basically making us logically be there in the cloud. So this IP address we got obtained from the NAT, which is assigned to the tunnel adapter here. This IP address. And you can now route to anything you like, whether it is private subnets or private subnets or public subnets or any other. You have another one there. You can basically go anywhere you feel like. You have more subnets there, you can go there also. As long as they are in the same VPC, you have no problem. You are already in there. You basically logically placed your person, this person, logically sits here now. This is a logical Nilesh. This is the physical Nilesh. So the employee, you just logically move them in the cloud and they can do whatever they feel like, any area. There are no restrictions. There are certain use cases where you want things like this to happen. Like, you have your employees who need to know, who need to go, can go. You give them a proper certificate, they can enter and do whatever you want them to do. And that's the use case where you just saw me complete that use case of using a VPN connection to your own cloud, and you get in there logically. Next, what I want to do is see what these boxes are doing, A1 and A0, and do they have Docker containers in there? And are they running Nginx? Let's go check. So we have this machine. This VPN will stay active, keep it active. So I'm going to just, keep it on the side and leave it active. But in this window, I will make it a little bigger and connect to the box, that box that we have there called app0, and it connects. Now let us see what do we have here. Docker ps-a. I think it goes. Let's see, Docker is running here or not. No. Sudo su. Now we should be able to see Docker. Docker ps-a, and we have Nginx running right there. So we have a Nginx image running, Nginx command. In that box, it is exposing port number 80 correctly, which means we should be able to say curl localhost and see the output of this welcome to Nginx. And by the way, this is the box number 233. So what is it called? Back in here, the 233 box is called app0, right? This box, app0. So this box number, IP address 233, has a name app0. So we'll modify this particular output that you see on the box when you locally visit the IP address. I want to modify this output. So I will make a change just so that you can understand load balancing. So what I'm doing is basically modifying something so you can visually see the difference between app0 and app1. Otherwise, they will all look same to you and you will say, what's the load balancing now? They all look the same to me. That's the reason why I want to change machine A0 and machine 1, app0, app1, make it slightly different. Before I make that change, I want to check the other box. So the other box is a different IP address, 10.128, but the IP address is this one, 173. So 1.73. Can I go to app0 and app1 also? Let's see app1. Do I let in? Am I allowed? Yes, I am allowed. And I got it. I will go su and see Docker. Are you running? And it is. Are you running Nginx? Yes, you are. Are you exposing something on port number 80? Yes, it is. So let's go see what do you have. It shows you localhost. Nice. However, both of them are running, but they all look identical because they are exactly Nginx boxes. That's what you will see when you visit this load balancer. Where is that? Load balancer. This one. When you visit this load balancer, it shows that it has this name, DNS name that you see here. So you can see this name, copy the A record, and open it up, and you should see welcome to Nginx. The load balancer itself doesn't run any Nginx applications. Let me clean up my whiteboard and I draw the concept more clearly so you understand load balancing also very, very succinctly, because it's an essential ingredient to scaling. And so what I'm doing is deleting a bunch of things here. Go. Yeah. So what I'm basically looking at is this load balancer, which is what we just hit. This user came and hit this box. This box is the load balancer. That was the IP address that the name that I typed in here, that I will also give it to you, by the way, in Slack chat. So you have it. You can also hit. You will all see the same page. Where is this page coming from? It is coming from either here or here. But we don't exactly know where it is coming from, because this guy is actually balancing the load. So by the way, these boxes called app0 and app1, they are running Docker and Nginx is inside. And that's what you're really looking at from this load balancer. The applications do not run anything directly, but they run it in a container. That's the design that we have. You will also notice that this NAT box is also a container, and we are running our OpenVPN software in that container. So with that design, you see that if you hit this machine, it looks like Nginx. If you hit this machine, it looks like Nginx. So you really cannot tell. If I repeatedly hit this site over and over and over and over again, you cannot really tell which box is getting hit because it is getting distributed. By the way, you should also hit the same site and see the output. You will all see the same output. So it's not really different. How do I tell whether load balancing is actually operational or not? And I want to show that to you. How do you actually tell whether it is really working or not? There are a couple of ways. One of them is a simple way. The simplest way is to just ask, hey, Amazon, do you think both of them are in service? And Amazon will tell you, yes, they are. They are in service. So it says in service. And this is box number 0, and this is box number 1. Both of them are in service, and all that is good. But that doesn't satisfy me. I want to go in the box, not from here. Go in the box from here, where I have a VPN connection in place. So I am in the box already. This is box number 73. So now here I will go and modify some things. Like, for example, I will say cd user share nginx HTML. And am I in the right box user? Oh no, I have to go to the Docker container, not in the box. Nothing is in the box. That's why I don't have that directory. So I'll have to go inside Docker container, which is docker ps-a, and we have this Docker container running. You need to go in the container to make a modification to a file that will make it visibly different from the other file on the other box, the other container and the other box. So it's a slight change. I will go inside the container, tweak a little bit to really tell how this load balancer is working out. That's what I'm doing. I'm going in the container now. So docker exec. And let me go to number 2 Charlie and give me a bash prompt. This number 2 Charlie is the identifier container ID, 2 Charlie. So I'm now in the bash in the bash prompt inside Docker container, where I can see user share and nginx and HTML. And here I will modify that file. We are not found. I was expecting that. Containers are really small and tiny, so they don't have much extra software. So I need to install VI software, which is also not installed by default. Then I can edit that particular file, the HTML file. And okay, this means that the apt cache is also stale, apt-get update, and then install Vim. So I can edit that file. So I'm doing that apt cache update. Then I will install Vim, and then I will use the editor to edit that particular file, the HTML file that you see when you visit this page here. Here, this one. And so that file is this index file, index.html. I want to modify this file and say, you know what? It says, welcome to Nginx. So this is the box number, app, what is it, 0 or 1? One of those, so app 1 Nginx. Now it's saved. So I'm going to save this file and come out of the container, come out of the machine to my local machine right there. Now let's go visit this. So one of the box I modified, the other one still looks like this. Now I'll refresh. So click and click and click and click and click and click. Now you can clearly tell that it is actually balancing load. Can you not? I think you can. I think you understand what I just said. I think you understand the fact that it is actually balancing between these two boxes. One of them I modified a little bit to make it look like this. Welcome to app 1 box running Nginx in a container, as opposed to this, the plain welcome to Nginx message. Just modified that a little bit. And this is just to illustrate that our load balancing is happening in a method known as round robin. Round robin is very simple. Just go here, go there, go here, go there, go in a circle, come back to the origin, go again. So if you have multiple machines, so say erase. And if you have a bunch of machines out there that are, all scaled up, scaled out, you have this machine, this machine, and more of that. And so you will basically round robin go like this. So you do this, then you do this, then this, and then back here, and like that. So it's a circle. That's the concept of round robin. That's the dominant scheduling load balancing algorithm you will find. Everybody will by default do round robin. There are variations to this method of balancing load, which are weighted round robin, not round robin, dedicated, and bunch of others. You can customize whatever you want. This balancing principle is programmed here in the load balancer. That machine really decides whether you go here or go here or here or here or wherever you go, and what's the policy you will use to distribute the load. The load will basically come from these users that will hit the box, and multiple of them at the same time. And this is the purpose of this load balancer, is to distribute load. That's what you just saw in real life. Any questions on this load balancer thingy? Anybody? Nobody?
No.
Okay. So you should also see the thing, by the way, if you hit that link over and over, you should see this thing showing you different things. Now I will deliberately kill one of those Nginxes. For example, I will go to this machine, and in there I will connect to the Docker machine, the Docker instance. Rather, I'll kill it. How about that? So here, hold on, let's see. Clear Docker ps-a. We have this container running, and what I want to be able to do is basically terminate that container. So I will basically kill one of those boxes. So you will see as a consequence that the load balancer is smart enough to detect that one of you died. And that detection happens through another method. This method of detection, I'm going to kill, by the way, eventually I'll kill one of those guys, but I want to give you this clear idea about what happens when you kill something. When you kill something, you will find that the load balancer here, this guy, will detect that one of you is out of service. How does it detect this service, whether you're in service or out of service, that status? It has to detect based on a method that you decide what that method is. So you have to really tell what method you will use to detect whether your boxes behind the load balancer are in service or not. The burden is on you to decide what would be the method to check for health. And that method is called health check, which is right here. And so in that method, I defined what I want to use as a method to understand whether a machine is alive or dead. And so the policy that I have put in here is the health check method is to ping the target, basically look at the target through HTTP protocol on port number 80. That's my method. If the machine on the other end responds back within a timeout period of 5 seconds, then you say that, yeah, the machine is okay, it is in service. And you repeat this every 15 seconds. And keep doing this test. Are you alive or not? Are you there or not? And if you don't respond, what will I do? I will shoot the machine in the foot, maybe in the head, and get rid of, and put a new machine in place. I can also automate that policy. If I find that a machine is dead, I can, have a gun pulled up, a figurative gun, and have the machine shot and a new machine to replace. That will happen if you have an automation for scaling put in place. But we will get to that point. What I'm talking about is basic concept of checking whether you're alive or not. And the method I have deployed here is actually written down in the code itself back in our app servers, where we define a health check. And the health check is defined right here. But I say that the health check needs to be look at the target with this port number 80, use the HTTP protocol, and check every 15 seconds and timeout in 5 seconds if it doesn't respond. And that's the idea. So we will now see this thing going unhealthy because we are going to actually shoot one of the machines ourselves by going to the machine. And in this box, we have this Nginx Docker container running. I'm going to kill it. So here we go, Docker rm to Charlie. Go bye-bye. The container is dead, which means our local host will not respond to anything. Curl local host will say, I don't know what you're talking about. That means our health check will fail. And so we'll just refresh, and you will see that one of the boxes, the health check fails. And so health check instances, both of them still showing service. That's lie. We know it is dead. So refresh, yeah, it's dead. So you keep refreshing, and the other machine is dead. You keep refreshing here, it's all going to the same box, the box which is actually in service. And so the other guy should say out of service. Yeah, there it goes. It went out of service because we know we killed it. And so it went out of service. That's the concept of load balancing, as you understand. I think this part should be clear. So after having done this work to understand and automate what we just did in the other exercise, we extended the concept a little bit by inserting other elements, such as we inserted the exercise we did in the very first cloud technology segment did not include Docker containers, did not include this concept of load balancing across two Nginx containers running here and here, and did not have this ELB. We did not have a NAT box running your OpenVPN software. We did not have that elaborate depth when we were doing it manually, mechanically. However, at this moment, it is super easy to automate the whole thing. If I just say get rid of all this and say, you know what, Terraform, please destroy the whole goddamn thing. And so it says yes. So please go ahead and kill everything. It will go and kill the whole thing. And so it will kill eventually. And when it does, we'll say bye-bye to these guys. And at that time, we can basically recreate the entire setup, just like it is right now, by putting all these files that we have in the Terraform folder, not in the hold folder. Hold folder is basically useless now. It was purely for illustration, so I can actually delete the hold folder. We don't need it. But the key operative files are right these guys. Item by item, they develop the cloud that we want according to whatever we decide. And it is very repeatable. Once you set it up, you need to also follow those creation of a certificate authority process, which is defined in this file here. And then you can get a certificate for an employee like this one and do it for other employees as you have. But not every employee needs to go to the cloud and be rampant at killing machines. So you be conservative as to what you really want to enable and allow only those people that need to go, get them in, but not everybody goes in the cloud. There is no reason. There is no reason for everybody to enter like this. There are certain cases where you need to let people go in, and that's fine. For that, we have this VPN method. There are other methods also, like direct connection using a fat pipe from your company to the cloud. That's also a method. A variety of methods available. But this is the most cost-effective method of connecting to your cloud without having to worry about all people need to do in your company is to use a certificate. Hold on, not here. Use a certificate like here you saw, and off it goes to establish a VPN connection that gets you a local tunnel adapter, and you're basically practically done in what you just accomplished. So I'm going to break all these things, by the way, and I'm going to close out all this. I'll kill it afterwards. But I want to take a moment to break for a few minutes and resume. And in the interim, if you have any questions, please keep them coming. So we'll take a short break, say about up to, what time was it? 6:26. So we'll resume at 6:30 or so. So 4-minute break, and we'll briefly recap what we did, understand what it means, and discuss something different. I am walking away from the computer right now, which means I will not be able to answer your immediate questions. So hang on, I'll be back in just a few. Hey guys, I'm back. So, are you guys there? I see you.
Yeah, I'm here.
Okay. So, questions are welcome on this this thing we just did in terms of how the use case of this and how do we put this to practice. The load balancer concept is actually pretty darn useful in a variety of scenarios. And I'll discuss those scenarios also with you after we conclude this specific exercise. I'll also point out a couple of things that are interesting that you can enable. I'll just get to that point. Hold on. Architecture. That's what you will find. The service that you saw that we used is this load balancer service. It's a ready-made service that Amazon provides. Like right there, load balancing. And that is something that you may not want in other clouds. And so in that scenario, you can put your own load balancer. How do you do that? That is also another exercise somewhere here. Where did I put it? Yeah, there is a HA proxy. Let's go search. HA proxy. No, not here. Somewhere there is an HA proxy exercise. I'll find a link for you and send it over. The idea that I am describing to you is that not every cloud will have exactly the same types of services. And so you want to enable the same ideas in a variety of scenarios, you can actually do that effortlessly. And what you need to be able to do is use an open source software, which is the underneath under the covers. That's what this ELB actually uses, is this thing called HA proxy software. HA proxy is available in this location. And the name of this application is a reliable, high performance TCP and HTTP load balancer. That's what it does. And if you look at the picture, it's high availability proxy. So there are two things on the front end to balance, multiple things on the back. So H and A, high availability. You can have put two on the front, making it higher availability, and PROXY as other boxes that is going to proxy. And so this is how you can enable. What you need to do is this H box and the A box, both of them need to run this software, which is 169. That's the latest version available. It is available in Debian repositories, and I don't know if there's a Windows version or not, but Windows has its own solution, so you don't have to worry about that part. This thing is available in app repositories in Linux. You can just install it comfortably, one line, and configuring it. Configuring is the hard part. So the configuration part, let me see if I can pull up some nice configuration information I might have in another location that I may. HA proxy. Yeah, here. So this is the configuration. That's how you write a configuration. Let me just briefly describe the concepts for you, and I will paste this for you to understand. You can actually hold on, cancel out. I'm going to paste this file to you in a snippet, and this is a HA proxy snippet that you can put to use. Pretty much it constructs a load balancer. So if you start looking at the code here, you will have a global section, which you don't have to change much. But the real changes you want to make is with the front end. And the front end HTTPS and the back end devices. So on the back side is what you put. In our example here, I have 4 different machines that are going to act as a back end And in the front end, we will have HTTP as well as HTTPS. So this segment is what you actually change. Everything else you can just use as is. And you put this configuration in a specific location in the in the folder in var live proxy location, I think. I'll exactly find out where this file goes. This file is known as HAProxy CFG. This is the configuration that needs to become available to those boxes that become your high availability proxy. Basically replaces this thing called the load balancer. So in our example, you have a load balancer service available. You will use this software on 2 different boxes and configure them using the example I just pasted in Slack chat. There is a properly written write-up available somewhere in our site that I will find out, that you can actually flow step by step and construct your own high availability load balancer solution using open source product HAProxy. This proxy is the forward proxy. Like we discussed in the previous example, we discussed Nginx reverse proxy. This reverse proxy, what it did was you have a name that you want to go to. It will, based on the name, it will resolve to an internal box and send your traffic there. Whereas in our example, which is a forward proxy, what we are doing is we have a common same name here. All we are doing is more like load balancing. Whereas here, we have various multiple names. So we had CNN.com, we have Times.com, NewYorkTimes.com. We have multiple names going to various boxes. Different, this name goes to that box and the CNN goes to this box, like that. So we are doing a reverse proxy idea in that implementation. Whereas in the forward proxy, we just have one name, the same name for every box, and we are load balancing. That's what this load balancing service does. That's what this HAProxy software does. You can also use Nginx as a forward proxy, just a different configuration file. And these examples are written down somewhere here. I will find a link and paste it for you. They are in somewhere in this site. I don't exactly, I'm not able to find it quickly. Having discussed this, what I want to ask you is, if you have any questions on this concept, please ask away, because I will change topics a little bit and actually discuss a new, fresh case, which is not available anywhere. So it's a new idea that I want to just throw at you and see how you actually will think through and help me solve that as a problem. So I will describe that case in the next 5-10 minutes. But before that, any questions if you have on this discussion we just did on load balancing and automation of a particular layout, particular blueprint that you have that we put in this, where was that? This location. So in this location, we have a master branch which works with the old version of Terraform and a develop branch which works with the newer version of Terraform. And you have that code available here that we discussed. We ran through this blueprint and we got it to finally work with the newer version also. That's what you're looking at. So questions, if you have any, before we move on to the next topic, which is a case study. Questions are welcome. I'm just waiting for, if there are any, please ask away.
Question?
Yes, sir.
So from a SOX compliance perspective, a lot of our servers are not allowed to access the internet. I haven't seen that workflow yet where, so most of these servers that you're setting up, they have straight internet access, which in my previous job, that was not allowed. Is that something that?
So straight access only for this box, not for these guys.
Oh, okay.
So these guys have no direct way to connect. So this is a private subnet. It's a public subnet. This one has. Yes, we decide it like that. We can construct a variety of use cases. Like if you have a use case where you do not want any public access whatsoever, that is a valid use case. Nothing wrong with that. For that, you would not want to actually construct something like I'm describing here. Like you don't want that NAT box already at all, because you don't want your machines to go out to the internet. So you don't need a NAT box. So you don't need this box dedicated to you. So you basically go back here and say, you know what, I don't need you. So you just put it on the side. You have multiple subnets, and all of them are private subnets. So this is a private subnet. This is also another private subnet with a different purpose. And so you can construct a cloud just like this. And by the way, in a private subnet, you will not have these people. This load balancer will not be there. These people will also not be there at all. They will all be in your company. They're not customers accessing. This is a private area, right? So this is all private cloud, completely private. But then how do you get in there? How do you go? How do you use? You have to have some method. So there are multiple methods of actually reaching from your data center. So this is your data center. And so you have your people, and your people are working in your data center. So this is your DC. This is your corporate office. But this red line is a completely isolated segment in the cloud. And even your people cannot go there because there is no way to go. So you can resolve that a couple of different ways. One of them is to ask the cloud provider to give you a direct pipe. This pipe basically gives you a direct dedicated connection from your data center that goes straight to the VPC. And once you have a connection, this is on a local network. This is not on the internet. So your local network that you have in your company, inside your data center, that's what you extend and get a direct connection to your virtual private cloud. And nothing of this will actually be able to go out because there is no route. Your employees cannot even reach there unless there is this local network connection. This is an expensive way to solve that problem, but big companies have that kind of money, and they find it appropriate to use that local kind of connection that you can establish. And here is my example. You can go here and say network direct connect, and then change it to your local area, and then say, you know what, give me a direct connection. So you can call it whatever you like, and your 10 GB connection, click and create, and here you have, you requested it. Looks like I need to delete it quickly before they charge me money. Delete connection. Okay. It's probably a paid service. So I deleted it. They're probably not going to hit me a bill. However, a letter of authorization is required, connecting facility agreement directly from the console within the next 72 hours. The next step will be to provide the letter of authorization, connecting facility assignment to your network provider or the co-location provider. So connection was established, but this authorization is needed for the cable company to make a direct connection between your company and Amazon, as an example. So we deleted that connection. But if you had that, if you gave an LOA CFA letter, it will actually, your company, Equinix company, will make that connection for you between your office and the Amazon cloud. That's the local connection you will establish. That's one way to connect. If you don't have that kind of money, and you're a less than a big company, somewhat, maybe a startup, what you would do is that you still want a setup like that, which is completely isolated, and it is not able to be reached from outside. You will actually construct one more subnet. And this subnet you will call a public subnet. Everything else is private. This is public. In that subnet, you will actually create one box. So like something like this. And in that box, you will install some OS like Ubuntu and mark it your jump box. Mark it as your jump box. basically label it as your jump box. So marking is basically labeling it. So thinking that it is my jump box. So that's one way. This is one of the first exercises we did is to set up a jump box, if you remember. That's the cheapest way to get in. So these people in your startup can just set up a jump box and connect to the box. And you can then do the SSH tunnel method, which is one of the first exercises that we were able to do. If you recall, that exercise is available in, where is that? Somewhere, no, not here. In the cloud technologies section, there is an exercise on that, which allows you to connect through a jump box. So you will see that somewhere here popping up as soon as the site opens. But this jump box lets you go. And once you are in here, then you can go to any of these boxes internally, although the boxes themselves will not be able to go out. That's the cheapest scenario. The next slightly better scenario is to actually not use it as a jump box, but instead use the exercise we did just now, like right now, just a few minutes ago. What we did was to not worry about a specific SSH jump box, but actually put VPN server right there. And let all your employees that need to go in, instead of going like directly, which you cannot, you go through the VPN connection that you establish, and your entire cloud appears to be your local property. And so your people can then connect any of these boxes. That's it. These boxes cannot go by themselves go out. They can if you allow them to, for which you need a NAT box, or you can use this box as a NAT box. And then you allow, and then traffic can go. But it's your choice. If you don't allow this, and you don't even have an NAT box, too bad. Your servers cannot go out. And that's the scenario. There are more scenarios like this you can construct. By the way, there are 3 or 4 examples that Amazon gives here. But you can, of course, construct any scenario that you like in this layout. There are, I think, 3 or 4 examples given to us by default. But you don't have to stick to those. You can construct whatever you feel like. You can just start this wizard. There are 4 examples. Here is one example. Put everything in just public subnet. This is a bad example. Don't do it. Don't use it like this. You put everything in the public subnet is a bad idea. This is like DigitalOcean. Don't do that. Here, you carve out a private subnet and keep it private. You have a public subnet. This is the design that we just put together in our example. We had a public subnet and a private subnet. The private machines here can go out to the internet if they want to here, but they have to go through the NAT device and then they can go out. That's one design. There are more designs. Here is one. You have a corporate data center at the bottom, and you don't want your private subnets to go out anywhere on the internet. So you don't even give them a NAT device. In that case, they will never go out to the internet, which means you cannot update your boxes. But that's okay. You just understand that you cannot update them. And so, but you still want to access, you establish a VPN connection from your corporate data center directly to the private area. And you can just go anywhere you feel like in your private and public subnets within the cloud through the VPN connection that you just established, which is also another example we did today through our open VPN connection. Next up is the 4th one, which is there is no internet. All you see is your corporate data center and a private subnet. It's a private cloud, private subnet, no connection to the internet, no nothing else. All you do is you connect to the machines from your data center and you come back home. That's it. There is no other way to go anywhere else. That's another way of implementing. And you can basically construct anything you like because you know how to put things together. You can do that. And the best way to accomplish what you want to be able to do is actually this method, the Terraform method, where you basically go out file by file describing how would you like my VPC, how will I like my NAT server, how would I like my private subnet, public subnet, security group, this and that. You basically call it out in succinctly simple language, which is here. It's not that complex if you think about it. Just set up a provider for Amazon Web Services, use the access key, secret key region, and define a VPC. And all of this is very well documented in the Terraform website. You can go to this site and read the documentation, and extensive documentation is available for every provider. You can see all the names right there. All the big names you will have, even small names. Like here, small one. So I hope that answers your question. Was that David, right?
Yes, sir.
Okay. Any other questions? Okay, then here comes a case study. It's a question that I will ask you, and I would like you to participate and think and answer as to how would you do solve the problem. That is what I'm going to define. I'm going to define the problem. The problem goes like this. It is a case study on enabling what could be known as, it's a fictitious case study, by the way, fictitious. It's fiction. So fictitious case study. Just like we have E911, I would like to enable V911. That means video 911. And so Obama says, here is unlimited amount of money. Take it all you want. I mean, just kidding. But yeah, it's all fiction. And some assumptions. The assumptions that we have is that everybody in the US has unlimited bandwidth on the iPhones. And by the way, everybody has an iPhone 5 or higher. That's what everybody has. Everybody in the US have unlimited bandwidth on their phone, and they have an iPhone with them. That's the assumption. Also, assumption is Obama gives you money. And the scenario that Obama wants you to implement is to enable a video 911 capability. So anytime you have an emergency, you make a phone call, 911, and you call the emergency service. The emergency responders will then ask you questions and basically decide what to do in the case of emergency. Is it a police-like emergency? Is it a ambulance-like emergency? Or is it a fire-like emergency? So whatever that scenario may be, or any other type of emergency, we don't know. So they will decide based on appropriate action that needs to be taken, based on what that situation is that you may be dealing with when you call 911. The new case is to enable video 911, meaning you will invoke FaceTime when you dial 911. Automatically gets invoked FaceTime, and police or the emergency responders will be able to watch what your FaceTime is showing on the video. That's the scenario that Obama wants to implement. It's a fictitious exercise, by the way. So it's a fiction, and that's what Obama wants to do. So he's given you unlimited budget with the assumptions that everybody has unlimited bandwidth and has iPhone, which has FaceTime, and now think. And the thing that I want you to think is to help me understand how will you think to begin to solve this problem. Of course, we cannot solve this right here, right now, because many of these cases are fictitious. However, what I really wanted to find out from you is to find how you think. How would you solve this problem? How would you begin to think in the direction that will eventually solve the problem of enabling video 911 capability. So that's the thing that I want to listen for from you as to what do you think if something like this pops up on your project radar and you are given budget, you are given resources and some assumptions to work with, and you are given the charter to implement it across the US. That's a large project, really large project. But how would you begin to think about solving this problem? That's the question. And at this moment, I will actually listen, not talk. So I want you to tell me, how would you begin thinking about what would you think, what information would you need, and what information would you want? How would you go about gathering it? How would you validate your hypothesis? How would you basically construct a plan towards a solution? So with that, I will take a pause and listen. And anybody and everybody is welcome to chime in. You just open your mics and I will open it for you. Unmute everybody. Here we go.
So first we need to, FaceTime is something that is not, it is optional. It has to be enabled.
Yes, you're enable. Somebody has to automatically enable. So you have to make some changes in the phone design itself.
Right. When the call goes to 911, the FaceTime has to get automatically enabled.
Yes. So when somebody calls 911, we have to somehow activate this and make it stream.
Yeah, it has to override user settings. For
Yeah. So that's one thing, right, that you would do. What else? Like keep going in terms of thinking what elements need to be put together on the user side, on the network side, on the cloud side, and other things, and a bunch of things involved. So basically, the end-to-end game. Here is the 911 caller, and here is your emergency operator. And there is some cloud solution you have to put in place. There's this police, ambulance, fire. All these guys are available at your service. And so that's what you have. The thing. So you have to basically put together in terms of thought process what needs to change in order for the project to complete. So think like that. And help me to the extent you can think, keep going. So one is a very good one. Automate enabling FaceTime, make it start streaming by itself when somebody presses 911. Bingo. Yes, what else?
You need tons of storage for all that video you're going to stream.
Oh, yes. A ton of storage. Yes, exactly. And you need to archive it for long term. There are retention requirements,
Right.
So retention has to be there. What else?
So
High bandwidth.
the network.
Yeah.
Bandwidth. How would you estimate? So the network bandwidth you have may not be, there is no such thing as unlimited bandwidth, right? You have unlimited data plan is possible, but unlimited bandwidth, there is no such thing. There is no such thing. I mean, it's not practically possible to have unlimited bandwidth. Yes, you can get unlimited data, and many of us have it already. By AT&T and T-Mobile, these guys give you unlimited data, but that doesn't mean that your bandwidth is unlimited. It just means your data is unlimited, right? So you have to estimate how much bandwidth is needed. This estimation is needed. For every call, you have to estimate bandwidth. And you also want to estimate a bunch of other things. So it's mostly an estimation exercise. It's basically begins with bandwidth estimation, but you have to keep estimating a bunch of things to actually simulate and eventually implement a solution for a pilot, like a small segment of the population. Then see how the pilot goes, right? And then extend. So if you start estimating bandwidth, how would you do that? You would something like pull up the iPhone and say that I want to see if I can project
Variety of trials and pilots you could determine.
yeah. So here is the iPhone that's coming up. And so what you would do at the very beginning is to just go to the settings area and find out how much is the data consumption right now. So you go to settings, cellular, and say data consumption, and you have this data that you have. So at the bottom, there will be a reset statistics. So you reset all of them, and then you have current period data consumption, cellular data usage, 0 bytes. So you reset the whole data usage patterns. Then you start a timer and actually make a FaceTime call to somebody. And so you say, call somebody, just like that. So make a test call with some person that you know and measure how much consumption that happens on a 2-minute, 3-minute long FaceTime timed call. And then you come back here. And then the data usage you will see again. And this number will change. This number will become different. And so if you know the information that you just captured based on, let me disable this display. Come on, go away. Where is the go away part? Here, turn off. Yeah, so it went away. But the thing that I'm describing to you is the aspect of estimating bandwidth. How do you do that? So you basically initialize t equal to 0, make a FaceTime call with somebody, maybe your friend or colleague, and maybe make a 5-minute video call, measure it, time it, and measure the data consumption before and after. And that will give you the estimation needed on a per minute basis, how much data is used. I actually ran this exercise myself, and it turns out you require 1.2 MB per minute of consumption on a typical FaceTime call. That was the approximate number I was able to get. So that's the kind of bandwidth that is consumed from an end user's perspective, who is basically sending video out. So 1.2 MB per minute. You divide that accordingly, and it will get you the appropriate bandwidth on a per second basis. So this is the megabytes, by the way. And so you have to convert that into megabits. And this is per minute. So per second, you have to convert those numbers. And then this will translate to something like 1.2 times 8 becomes bits, and then divide by 60 becomes per second. That will give you Mbps, this number. And so that's the estimation of bandwidth that user needs to have. Now let us understand a couple of other things. Let's see, this is the US. This is my broad, rough map of the US. So you have Seattle here and Florida here and New York here, for example. Now you look at the entire map and you will find that it is divided in states. And then within the states, you have this thing called a county. Every state has a bunch of counties. These counties is where records are kept for 911. And so you have to identify a good example county to begin working with and understand how many 911 calls happen in a year. because what you're really trying to accomplish is put together a system where you will have some kind of a cloud deployment, where you will have a bunch of course, storage. So here comes storage. And you will have a bunch of these boxes to listen, and your applications will run here that will actually receive incoming video feed. So you will have pretty much conceptually similar structure where you have a storage server, some kind of a database, some other things in place, such as a load balancer, and a private and public cloud to begin with, private public subnet to begin with, and then your IP flow of video calls, like this user, for example. This user, he has a phone in their hand, and that user will make a phone call, and you will receive traffic. You will receive incoming video. So this video feed is coming in from this user, and it will come at certain Mbps. You need to take that incoming video feed and start saving it. First of all, as it comes, dump it.
You want a big database, right, to track all your users.
Yeah, so you have a database going here. You have storage going in some kind of a blob store. So, like a S3 or a blob store from Azure, you can use one of those. You can have DocumentDB or SQL DB that you run here. So you will have a database to store your user information, the date they call, the time they call, how much long they talk, things of that nature. But your video feed that you're not only watching, so that this emergency operator will not only watch that video feed real time, but also send this video feed over to the processing units, over to the storage for reference and archival. And that estimation of how many users will you have calling you, you can very quickly do that by making a query on Google. How many 911 calls are made per day? So there we have 240 million calls are made to 911 each year. In many areas, 70 or more are from wireless devices. So that's the statistics. National Emergency Number Association is giving you statistics already. So you will use that to estimate call volume, and that's a hefty number. 240 million calls in a year, approximately estimated. And quite a bit of them are from wireless devices, like iPhone, for example. And so the idea is that this is a national number. So you want to narrow it down to a county by county, so that there is some data available somewhere where you can actually search per day in King County. And you will find that the county will disclose the E911 program. They will probably have statistics already. So, they don't seem to publish statistics, but you can always get, once you have that kind of a budget and a mandate from Obama, people will give you data. So you will eventually find out county level data as to how many, there are 12 call centers already apparently. So you have 12 locations where people are listening to inbound calls, which means you have something like this emergency operator. There are 12 of them just in the King County. So you have to have 12 viewing stations. So, if you now compare this same idea and contrast it with what we discussed early on with a case study that we did, let me pull that up again. So you have a very good refresher on that one. You will actually relate to it very easily. And so it is the Netflix case study we did. It's conceptually very similar, by the way. Let me just point out a couple of similarities there. Except the mode of operations is very different, but the underlying architecture can be broadly borrowed. AWS architecture, and here we have those diagrams. And if you go look at the media sharing scenario, you've probably seen this. We used this in a previous discussion with Netflix. So the concept, you can actually discuss the same idea, somewhat similar in here, in our black colored boxes, these boxes. these upload web servers, these job queue, and this processing pipeline that we have in the discussion that we had regarding Netflix. We will change that discussion somewhat. In that, what we will do is this upload process, these video files that are coming into the system, getting uploaded through this load balancer to the upload servers, which is then putting them in a media repository. These video files as they come. In our example of a V911, the scenario would be people calling in 911. And as they call, their video streams come. That's a streaming video coming in, which is basically what you would see in this example. This user calls 911, they're sending video. This Mbps frame rate, or whatever video frame rate is coming through FaceTime, and you're just receiving that right at this load balancer. And the first thing you do is you upload them as it comes, put them in a bucket. In addition to this, you also need to do one thing immediately, which is to make sure that you're not using any spot instances. Because this is an emergency scenario, you want to actually use on-demand instances with the regular price, not cheaper machines. And also extend this design to not only upload it to the media repository, but also share this video with your 12 call centers as soon as it comes. As soon as the video calls come in, like this flow comes in, you want to send a copy over to the repository. At the same time, share it, basically create a portal for the call centers themselves to listen to and to see what is going on in form of a video that they may see in some browser, which is basically the playback scenario of Netflix. So as soon as the videos come in, the first thing you do is to not only save, but also play it back, right? Like that. Web servers and load balancing. And this user, which is a E911 user in the call center, he or she is now looking at the incoming videos through this web server, which is basically showing you this incoming traffic that may be arriving from a 911 call that comes in. So you upload, and at the same time, allow your 911 operator to see the video that they are receiving in the system. To recap what I just said, I would like to describe this slightly differently again, which is you have multiple scenarios. You have this user, which is the emergency person who needs to respond to the emergency, and this normal guy, in distress. So this is the person in distress. He or she calls, and they're sending video. This video needs to be not only saved somewhere in a safe location, but also presented to this user, who is one of those 12 operators, one of those 12 call centers in King County. This is just the King County, by the way. So this is one of the 12 people, or maybe more than 12 people, but just 12 centers, where people need to see this video that comes in. And this has to be presented to them in a system that not only saves it here, but also gives them the opportunity to view it in real time. Now, having understood that part, the other thing that is relevant and interesting is to look at the ability to provide TiVo capability right to this guy, so that he or she can then travel back in time and replay what happened here. If this person is in distress, they can quickly resume and replay if something is serious or they did not understand. The fact that you are storing it in a location that is supported by a large-scale cloud infrastructure allows you automatically to TiVo it. Even if it is coming in real time, you can just quickly rewind and repeat and go forward and play and watch what just happened. And then that will give you better ability to detect the type of service that you want to dispatch. whether you want to send police or fire or ambulance or something else. We don't know, but having that ability to TiVo is the DVR, like you do in Netflix or YouTube, you will just rewind and repeat. Same idea. The fact that you record it gives you the ability to rewind and repeat. And you do see this capability already in your Lync software, or I don't know if they implemented it or not, but I think I've not been using Lync for some time. You tell me if Lync has this DVR capability included or not. Today, you know better than I do. So, but there was a plan at some point to implement DVR inside Lync. So if you are in a meeting and you suddenly get an emergency phone call, you walk away and you come back in, you miss a part of the meeting, you want to rewind and repeat, you can do that in a live meeting. It used to be called live meeting, by the way. It was, the old name was live meeting through Placeware acquisition. And that was the feature that some of us were working. I don't know if it is implemented or not, but you can tell me. So that scenario you can also extend in the context of a distressed person calling in, allowing the emergency responders from a call center perspective to do a real-time DVR replay, or action replay. That's the best way to describe. Although it is a sports term, action replay. But the idea is that you want to see what's going on here, what kind of a distress this person is in, and then appropriately, based on a more informed decision, you can deploy and dispatch appropriate help. So that's just one way of thinking. The other way to think about is to estimate how much bandwidth do you need here, how big fat pipe is needed. And that estimation, of course, needs to happen taken into account how many calls do you get. So we know in national level you get like some million calls, some 240 million calls, but you can just estimate or just assume that some number of calls you receive every year in King County, for example. So here is King County, and there are 12 such stations, and there are these people county-wide sitting wherever they are. And the calls will get routed here. And so you have to estimate how many calls will you get in a year, and whether these calls, all of them happen suddenly in the month of January, or they are spread equally over the period of the year, January through December, or how is the spread, how is the variability, how is the bell curve, if you will, of the calls that come along. So basically it is generally spread out all over the map across the year. But are there any patterns in the history that tells you that you need to be prepared better in certain months when it is going to cause fire, in the summer months in the parts of Washington state where it is very dry? Maybe in the summer months you want to maybe prepare ahead of time, so you want to have more infrastructure here to accommodate emergency that might happen more in the month of summer. Or maybe you have a different type of emergency that happens in winter, like snow emergency. So it really boils down to what statistics you accumulate over the past couple of years. And depending on that statistic, you might want to adjust how much equipment you want to put here for that to be able to comfortably handle your incoming traffic. One thing that you really want to remember, which is very different from any other type of scaling setup, is that this is an emergency service. What does that mean? The thing that you want to really remember is that it's an emergency service, which means it is okay to have low utilization. Nobody is going to complain if the utilization is too low. And I think that's a good thing. It is the same idea which I described the other day. I was saying there are 4 fire trucks sitting in Redmond Fire Department doing nothing all year long, and I'm pretty happy about it. And that is something that you want to remember in this specific example, is that even if your bandwidth estimation that shows you that the bandwidth needed for those, 300,000 calls that you get every month. You might need certain bandwidth that you calculate. It is okay to allocate all of those resources in an emergency setup, because what you don't want is line busy or unreachable when somebody attempts to call 911. You don't want a line busy signal to that person, because if that happens, your whole thing is screwed. And you don't want to screw people. This is an emergency service. So you better have more equipment available, and don't fall into the trap of, making sure that your utilization numbers are high and decent enough and budget and all that. That doesn't apply here. It's a different type of service, different type of use case. Don't apply utilization factors to emergency services. And with that assumption, understand what bandwidth requirement you have been receiving in the past and accommodate a little bit more than what you would otherwise see, so that you have some room or some slack for that actual emergency that might actually occur. It may not have occurred in the past, but what if something really goes wrong? Maybe, hope not, but something really goes wrong. In that case, you need to have that infrastructure to actually accommodate emergencies. And so that is the scenario that you have to really plan for, which is a different way of estimating capacity. And this capacity estimation, especially when it comes to emergency services, does not follow the norm. The norm in most cases that you will see is that, you need to have proper utilization and, make sure that your budget is accounted for and that you are not wasting money, and all of that is good. But cut all of that when it comes to emergency services, because you need to spend money. And you need to basically spend money because you want extra capacity, because you want very, very low response time. You want to immediately be able to respond, immediately be able to listen to and see what the video is being sent, and even have the ability to replay back, rewind and repeat, to really understand and comprehend at a very short notice, a very low response time, very, very quickly, and dispatch those services over to the end, the person in distress. And if you're not able to do that, the whole thing is useless. What's the point of having a 911 service to begin with if you cannot respond in time? And that is something that is a very different example that applies strictly to the scenario of emergency, that does not take into account these things at all. So you don't fall into the trap of making sure that your utilization is good enough. Don't do that. Not for emergency. For other cases, totally fine. What else would you think from a V911 perspective? What else can you extend? So we just discussed this about, say, one county with 12 call centers in King County, right? That's what we have. So how would you extend this to a national level? What would you measure? What would you see? What would you do different when you want to extend? What will you learn, or what would you attempt to learn from a pilot that you will do in one county to extend it to other counties and eventually to the national level? Anybody?
Let some end users.
Yeah, exactly. Exactly. No. Yeah, simulate.
You gonna go run around town and cause trouble, Nilesh?
No, that's not what simulation is.
Before that,
Sorry.
Before that, there is another technical blocker as well, right?
Yes.
FaceTime is supported only. FaceTime can be done only between Apple devices.
Yes. So that's a very good blocker. It's Apple only on both ends. So
Right.
on the sender end, it's iPhone. So that's okay. But on the receiving side, you need to basically request Apple to provide you codecs to decode and encode and process.
And that can be multiple platforms, like how Netflix has multiple platforms that it has to support.
Yeah, so we can reduce our variability, and you can just say,
Right.
stick to one Linux operating system. You can just simply say, let us play your codecs and decode your codecs, encode, decode, and process only on this dedicated system that we are constructing for V911. And Apple will more than gladly do it, because you're going to have everybody use the iPhone. They will gladly do it for you. They'll probably come and implement it for you. If the government decides it, everybody will have to have an iPhone for a 911 service. Wow. Apple will do it for you, the whole project. I'm not kidding. Apple will come and say, we'll implement the whole solution for you for free. Because on the other hand, everybody is going to buy an iPhone, right? That's a dramatic business game that actually, people might play, one day. One day it might come as a proposal from government, say, hey, Apple, would you implement? And Apple might say, yes, we will gladly implement. Because at the end of the day, they are selling more phones, which is their primary bread and butter. I mean, come on. So that might happen, but who knows? So yes, the license currently prevents running in a non-Apple hardware. You cannot really run those protocols and codecs. It works only between Apple and Apple. So, but you have to get that permission cleared out from the license holder and have it implement for a specific case. They might agree. And as I said, they might actually do it for you if you mandate this kind of a setup. What else? What else would you think? So pilot program, we'll also run some test users. So simulate them, test out, see how the response is. Pilot test users can be individuals. Test users can be your call center operators.
We talked about instrumenting the system.
Yep. Measuring it, how it's working at every stage of the game. So, your entire pipeline that you have here, which is
where the faults are coming. Yep.
Yep. The entire pipe as the traffic flows from the end user all the way to the machine where it finally saved here. And your entire flow of those videos that are flowing through the system, you want to measure the whole thing. How is the frame rate going? How is the quality going? Is it dropped? Are the packets getting dropped? Is the network working properly? Is the traffic flowing properly? Are we in a need to reduce our bandwidth because of AT&T sucks or T-Mobile sucks? Do we have to shrink, drop the frame rate or drop the video resolution to adjust and account for sucky bandwidth? Or all those things we have to accommodate and actually account on a live system. Once it starts to run in the wild, you will have network behave various random ways. And it will behave really, really bad when you really, really need it most. And that's the problem. When you need something really bad, it behaves the worst it can. And therefore, you have to plan ahead of that worst case situation where things will go wrong. And in that case, the fallback plan has to be absolutely intact, which is even if video doesn't work, your basic audio should continue to work seamlessly just like it did ever before. I remember having had the opportunity, I should say, to call 911. I had one day had to call 911, and within 2 minutes, the police came. And actually, it was the ambulance that came. I did not need police. So ambulance came and they took care of the whole thing. And the reason they were able to come immediately is primarily because they were doing nothing. I'm not kidding. It's a great thing that they were doing nothing in the fire station, and they just showed up here in a minute. In a minute, as soon as I called, the truck showed up. And that was possible primarily because of you're provisioning for extra capacity that you don't anticipate for. So you're over provisioning. And that's a good thing. And so this is how you broadly think about putting pieces together in terms of a net new project that you might run into, and you will extend and use previous similar analogies and extend, modify illustrations that you may have seen before, and begin to implement a pilot on a very small scale, test it out in your lab, then roll it out slowly to a couple of people, understand how it goes, and then scale it to a pilot county, or maybe just one call center at a time, and then expand it to the county, and then expand it to the state level, then pilot it in another state, and maybe 3 more states. Go to red states, go to blue states, and figure out differences, things like that. And I shouldn't say red and blue, but elections are coming. So they're here already, apparently, and I voted. So you should vote. And the idea is learn from other examples and expand and extend. There are various examples already available out there. You just have to find out what may be related to what you have in mind for a given case, and then apply. And that's how I would discuss this particular case. And any other thoughts that I may have missed in this discussion? Okay, looks like you don't have any specifics. So I will then point out that HA proxy if I'm able to find it. But that is something that I'm still not able to find. I will give you that link later. The HA proxy link is a very good exercise simply because it gives you freedom from using elastic load balancer. I am not against ELB, no. All I'm saying is that it gives you the choice to go something else, do something different that you can do in any cloud. It doesn't have to be this cloud. That independence from a vendor is what I'm really trying to advocate here, is to use open source product because it gives you the ability to do whatever you feel like, wherever you feel like. And that's why HA proxy. And not necessarily this thing called the load balancer, wherever that is. This is here somewhere. And I forgot to kill it. I think it is still running there. This load balancer is still active in the California region. Yes. So it is still there. Now my health check is failing on one of those, which is fine. Okay. Let us see on the HA proxy, how much time we have? 25 minutes. So on the aspect of things that we covered, which is automate a complete VPC deployment and configure HA proxy in that example that you saw. And we discussed this cloud formation the other day. Did we do that? This exercise? I think we did. In the cloud formation exercise is very similar to Terraform exercise when you design a template or you use a template to create resources. I think we did this, right?
Yes.
Yeah. So very similar with Terraform, except it doesn't do some of the things, like, it doesn't actually create a template for you. That piece is not available. You cannot use Terraform to create a template from your existing resources that you might have from the last time I checked. They may have improved upon it, but I think the way I seen Terraform work is that you go to the documentation site on Terraform, which is somewhere here. And then you understand what do you want to construct. You identify the appropriate providers. You go to that particular provider, let's say your Azure Cloud, and then you define a provider. You put your subscription ID, client ID, secret and tenant ID, whatever the provider gives you, and you construct a resource group. This is conceptually very similar to what you would do otherwise in the Azure console. So you go to here, manage.azure.com, and here I think I logged into the other account, not this. So I switch and then log into the other one, this one. I don't know what happened. sign in, this one. So it takes you to the Amazon, sorry, this is Azure Cloud, which is basically the same thing you would see in this documentation, except it looks, from a look and feel perspective, you will find that, where is Azure? Here. So you will see pretty much the same elements that you would expect to see in this documentation. So let's go start seeing those elements here. Here is an example, Azure Provider. You have a concept of a resource group. You can see the same thing in the new portal, apparently. That's where they have it. In the new portal, you can find out what resource group you want to put. This is like marking something in production, for example. And so you classify and call something in production mode and label it like that. You will also construct a virtual network. And the idea behind a virtual network, like is defined here, is the same idea that you have called a VPC. In a virtual network, which is so you saw a resource group. And here you can construct a new resource group by clicking a button like that, and then naming it something. And so you can name it something like you like, something here, some name here. You can do the same thing, and you can choose your region, let's say UK, US West. Come on, US West. West US, there we have. So we have West US, you can choose West US and call it production. So you can call it production, and you create. So it is going to create a new resource group. I don't know why it did not. Apparently I clicked the button, but it did not do anything. Resource group, please show me there we go, production. So production resource group constructed. And you can keep going like this. So now you can have a production network constructed, pretty much similar to what we did in Amazon, except terminology is very different. Here you have to construct a network. So you go to virtual network. This is like creating a VPC basically. So you create a virtual network and you give it a name like this and define a address space, which is this CIDR block. And so you define that address space. They call it address space. Amazon will call it something else. You can call it 16 to make it wider and to match what this example usage provides. You can give it a name for a subnet. The name that we have chosen for the subnet is default. We can have a subnet slightly smaller, /24, as opposed to full address space of the entire network is 16. And I think that's the biggest that you provide. Virtual network address range in CIDR notation. So we have given that. Let us see if Azure supports slightly bigger addresses. I don't think it will, but I'm just saying that will it. So if I have an existing resource or production, I'm going to create this production. You know what it does allow? It just set a green mark, which means Azure is wider in the address space than Amazon's. So here, I said 15, let's say 14. Will it say yes and allow? I don't know, let's find out. Seems like it is saying okay, which is nice. I did not know that. So let us see if it will let me go up to 8. Oh yes, it does, giving me all these addresses. How about even smaller? Probably not, it's not a private address space. So 7 will, still allowing me? No, 1 is not allowed, 2 should be not allowed, 3, not, 4 should be not, and 5 should be okay. So that's the max address space you can get. 5 is now saying no. 6, still no. It said yes a while ago. Now 7 is okay. So that's the maximum address space you can get in Azure, which is probably way bigger than what you can get in Amazon. Amazon is limited to -16. And you can keep going and create a new virtual network. So you just saw that. And it doesn't show me. That's the part I don't like about Azure. It doesn't show you right away. You have to go back somewhere and come back and find out. That's the hard part. So the UI sucks. Sorry, I just said that. So it should refresh. It should refresh by itself. So you now have a production network. We can construct more subnets like this. These are basically subnets you're constructing inside this VPC. They call it virtual networks. Basically the same capability that you have in Amazon, you will find the same capability here in Azure. And this is an example usage that you can construct in Terraform and basically apply Terraform plan, Terraform apply. It will apply the same things for you in Azure Cloud. And it doesn't have to be Linux. You can also include Windows here. And so you can basically specify whatever you want. Like here are examples of creating a virtual network. Here you can create a Azure load balancer. You can have this Azure load balancer is similar in concept to Amazon's ELB, where you can construct a load balancer scenario. You will have, apart from Azure's service, you will see more documentation on a variety of different clouds, such as DigitalOcean. So very simple one. The idea is to be able to define the token that you get from DigitalOcean and then create a droplet. So resource called a DigitalOcean droplet by the name web. So you basically put this and create a new server through Terraform. So it's a whole lot simpler usage of creating a domain, creating a droplet, creating a floating IP. There are not many things to do in DigitalOcean Cloud. It's a small, focused cloud. Whereas in case of other providers, you will have a ton more things to do. For example, Google Cloud, lots of things to do. You have a concept of a network, which is like a VPC, which is what you define in the Google Compute Network, the value of name of test and the IP address range of 6/16 like we did here, except we did a /7. You can do the same thing. They just call it network as opposed to virtual network. So same thing, different name, network, virtual network. And you will construct whatever layout you would like to see constructed in your illustration that you will have. So you have to basically write steps in that format, which is the TF format, which is what you see in this documentation examples, this example usage example. And this is exactly what you see in here. That we ran the other example today of TF and then Atom, Terraform. What you see are these examples are basically written exactly like what the documentation says. And so that's how you use that tool to build ability in your cloud for a given design. So you will implement your design pretty much like this in a variety of files by beginning with, let's say, have a VPC there. This is for Amazon. You will have a network for Google and a virtual network for Azure. And you can basically construct similar steps and run the same process, Terraform apply, to construct whatever you have in mind that you have written down in these files will actually get created in your cloud for real, for this cloud, for example. And you will see these things happening for real as you go and build your design, and that needs to be done in this type of language, which is the Terraform way of writing a blueprint for a cloud infrastructure for a given application that you will eventually deploy. And that's how you will construct things that you need. And this is a very easily maintainable design. It is not something that you will randomly create something by clicking some buttons in Central Asia and Western Europe and South India. You have a South India location there? Nice. I just saw that. I did not know. So they have a South India, Central, wow, Central India also. I had no idea. Central India is where my parents live. So yeah, nice. That's a good thing. I will play with it now. So Central India and Western India and all that. Okay. So the idea behind this technology, the Terraform, Terraform technology is to basically take a design that you construct like this, for example, translate that into, into this kind of a format. Your design needs to be converted into this format. And I gave you this as an example that works with the Amazon cloud, that you write like this and then play and apply, and then it builds the cloud for you. It builds the applications inside based on what you define, what you write in the configuration, and then some extra like generation of certificates and things like that. It's a separately, it's a manual process. I kept it manual because you want to control it. You want to see how many employees you have and you control issuing certifications. So you keep it manual. It's a one-time operation. But the rest of it, it can be automated as you go along. And that's the concept behind building something for yourself, for your company, in any cloud, as long as you're able to do it in a neutral fashion, as long as you use technologies like these, that gets you the flexibility and the ability to choose and pick your cloud, which is the best for your use case. It doesn't have to be one cloud versus the other. That's the overall concept that I wanted to talk about today. What we have coming up is only one day left, and that is on the 5th. We have the last day, and that is how things are. So what I would like to ask you is, I have a bunch of things that I wanted to cover. If you want us to discuss something specific, I would like you to point it out, call me, tell me, email me, Slack chat me. And that's what I would like to cover next time. In addition to what I have in mind, which I will, some of the aspects that I think are relevant, we will discuss those next time we meet, which is on Saturday morning, which is this November 5th. Now, having said that, one thing I want to say is that I would love to see if you have a brief description of how you think was this program. The reason I ask this specifically for all of you is to let other people in the future decide whether this program would be a good one for them. So what I would like to ask you is to please give me a short email that describes how you like the program, what you found useful, and whether you have some ideas that you want to share with me. So that basically I'm looking for feedback that helps other future participants in the program. And I would appreciate if you can send me a short email. It doesn't have to be long, just a blurb, one paragraph is too much. So just describe what you take away from the product, take away from the program. This Cloud Genius Bootcamp that we are running, it's finishing up. So the request is, send me feedback on what did you take away? Like, what did you take away, as in, what will you take from this and apply to whatever scenario you have in mind? That is exactly what I want to find out from you. And only you can tell me, because I have no idea. You can tell me what did you take away and how will you apply. That is what I will be interested in reading from you. And please write that to me in email, and you know my email address already. And if not, I will just paste it in Slack. So here is my email. Please write to me as to what did you take away from this program and how will you apply it to your future work. This will help other people decide in making the right decision on joining this program. That's all I ask. So we'll see you again on Saturday morning, 8 o'clock.
Thanks, Nilesh.
Thank you, guys. Thank you very much. See you Saturday.
Thanks, Nilesh.
Thank you, guys.